Good afternoon. Today we discuss about fundamentals of flight. My name is Mr.R.Karuthapandi, working as a assistant professor at Aeronautical department in PSN College of Engineering and Technology. What is flight? Already we hear about flight. What is that? Flight is the process by which an object moves through the atmosphere at whatever it may be, a bird, insect, flight, airplane, helicopters. These are by generating lift that contracts gravity, allowing it to stay aloft. All of these are flight. Types of flight. Flight is classified into two categories. First one is natural flight, then second one is artificial. That means man-made flight. Natural flight is nothing but performed by its living things, performed by birds, insects and bats using wings. Whose are there having a wings by fly own in respect. Example, a bird flapping its wings to generate lift. Then second one is artificial flight by man-made. In the recent days we using so many fighter aircraft, spacecraft, drones, UAVs and rockets, so many things. By the way, in this example, an aeroplane take off using engines and wings. The wings and engines are plays a vital role by the main man. Each and every wing designs aspect ratio should create a different lifts. Principles of flight. Flight is governed by aerodynamic forces, primarily described by Newton's law of motion and Bernoulli's principle. These two laws is very important to generate lift and go forward to make a thrust. There are four aerodynamic forces are involved to fly the aircraft, anything it may be. The four main forces are lift. The lift is nothing but upward force that opposes gravity using the wings. Then second one is gravity, downward force due to earth pull. It's automatically. Then third one is thrust, forward force that propels the object forward. It's very important by using engines. Then fourth one is drag, backward force due to air resistance. The drag is so many types: parasite drag, form drag, wave drag, interference drag. We see in later. Then this is the figure represents the where is lift is present and where is drag is available, and how the weight is activated, and the thrust is how propelled the aircraft forward. This is the schematic diagram for the aerodynamic forces. Lift. The lift is the main phenomena to fly the aircraft, counteract the overall gravity. Lift is mainly generated by the wings of an aircraft or the flapping of the wings in bats. The wing plays a vital role to make a lift, create a lift. By visuals of the aspect ratio and wing loading. We see these topics later. The shape of the wing is called an airfoil. It plays a crucial role. It follows the two principles. One is Bernoulli's principle and the second one is Newton's third law. We know about the Newton's third law. Bernoulli's principle. Bernoulli's principle explains how the pressure of a fluid like air decreases when its velocity increases. If the fluid velocity is increases, automatically pressure will be decreased. If the velocity of the fluid decreases, the pressure of the fluid will be increased simultaneously. It is a fundamental concept in aerodynamics, especially in understanding lift in flight. And the next, an aerofoil wing cross section is designed so that If we design an aerofoil, it has two curvature, upper curvature and a lower curvature. This is called camber. In some aerofoil designs have a bottom which is flattened, the upper curvature is too high. For example, air moves faster over the curved top surface, air moves slow under the flatter bottom surface. This is the main phenomena. In this phenomena, we generate lift according to the Bernoulli's principle. This is the schematic diagram. Then how the aircraft generate lift of an airlift. This is the trailing edge. Sorry. This is the leading edge. This is the trailing edge. The relative winds strike out the airfoil. The low velocity airflow under the airfoil. The high velocity of airflow over the airfoil. The red lines show the low pressure area. The blue lines show the high pressure area. This arrow mark direction of the flight. The lift due to pressure difference. Due to the pressure difference, the lift will be generated. This is the formula for lift. Half rho v square SCL. The half rho v square is the dynamic pressure. Already we know about what is dynamic pressure. Then S is the wing area in mm square or meter square. CL is the coefficient of lift. Depends on the wing shape and angle. V is the velocity of the flow, meter per second. The rho is the air density, kilogram per meter cube. L is lift force. It represents Newton. What are the factors affecting lift? So many factors affecting the lift, vice versa. First one is airfoil shape, that means wing design. The more curvature on the upper surface increases airflow speed, simultaneously reduces pressure. This pressure difference created the increasing lift. The more curvature means camber area. Okay, the next one is thin or flat wings produce less lift and highly curved wings. Thin flat wings are creating less lift compared than high cambered wings. Aerodynamically it is efficient. Then angle of attack. Angle of attack is nothing but it is the angle between the relative wind to chord line. Which means wing chord line, the angle between the wing chord line and the oncoming airflow. If the higher angle of attack means more lift we created. Low angle of attack means low lift we created. If the angle of attack is more than 15 degree, it will become stall. Behind a certain, that is called stall angle. Beyond a certain angle of attack, airflow separates from the wing surface and lift drops sharply. Once again repeat, beyond a certain angle of attack, airflow separates from the wing surface and lift drops sharply. Then third one is airspeed, velocity of airflow. The velocity of airflow determines the also lift. Okay, lift increases with the square of the airspeed. The lift is directly proportional to square of airspeed. If the airspeed is increases and also the lift will be increases. Faster airflow over the wing, which is equal to greater pressure difference. Then it is created more lift. Once again I repeat you, faster airflow over the wing created greater pressure difference, which create more lift. The next one is air density. This is rho, it represented by the rho. Dense air, which means more molecules per volume area volume. It is called as dense air. It creates more lift. Denser air create more lift. Air density increases with altitude, temperature and humidity. If the altitude increases, density reduces because the density has lesser dense, and also it's similar to the density is decreases and also lift will be decreases. If the altitude decreases, density also increases. If the altitude increases, the density will reduce, then air molecules is loosened and the lift will be reduced. The next one is, if the temperature of the air and the surrounding atmosphere is increased, the density will also reduce. By the way, the lift will be reduced, and the humidity of air will be increased. the density also reduced and the lift also reduced. These are interlinked process. Altitude, density, lift, temperature is prominent. If the temperature is prominently changed, the density and the lift will be affected. If the humidity is too high, the density will be reduced and also lift will be reduced. Then fifth one is wing surface area. Wing surface area, it is called as span. Larger wing area allows the wing to act on more air. The lift is directly proportional to wingspan. Aircraft with wider wings like gliders generate more lift at lower speeds. If we have wider wings like a gliders, we create more lift at lower speeds. Okay. If it's higher speed, means it creates 2 more lift. Then sixth one factor is coefficient of lift, CL. It's represented by CL. A dimensionless factor. It is a coefficient, is a dimensional factor. That means it has no unit based on wing shape and angle of attack. The coefficient of lift is depends upon the wing shape, how the wing shape is described, and the angle, how the angle of attack is we use. That these are the calculate the coefficient of lift. Determined. The next point is determined by wind tunnel testing or computational fluid dynamics. One is experimental analysis and another one is computational fluid dynamics. These are used to calculate coefficient of lift. Then the seventh one is wing aspect ratio. Aspect ratio is nothing but the wingspan of aircraft divided by average wing chord. Mean aerodynamic chord, what is nothing but high aspect ratio has long and narrow wings. High aspect ratio means long and narrow wings. Low aspect ratio means short and wide wings. If the high aspect ratio means more efficient at generating lift used in, for example, used in gliders. Low aspect ratio means short and wide wings. It's more maneuverable but less efficient. This figure show the wing area. The color of brown is show the wing area. The aspect ratio is we have the aircraft has 2 wings. The the tip of wing 2 and the another wing of wing tip. This is the span area. It represented by B. Then eighth factor is wing surface condition. How the wing surface is it be smooth or rough? That is classified by the wing surface conditions, and each material has different roughness, surface roughness. Sometimes the ice and dirt bugs can disturb the airflow and reduces lift. In some cases, ice will be formed above the wings, under the wings, the rain areas. In some lights has attract the bugs and it will death over the wings. It can disturb flow and reduce the lift. So due to that, we clean and smooth surface help maintain laminar flow for better lift. If the surface is too rough, it will create a turbulent flow, vortices. It will affect the lift also. Then the flaps and slats. Flaps and slats are secondary control surfaces. The flaps increases using curvature and surface area. Flap increase wing curvature and surface area. If the wing area is too high, we created more lift. And the next point is used during takeoff and landing to generate more lift at lower speeds. Using during takeoff and landing to generate more lift at lower speeds. At the time we using flaps, deflectors flaps to create more lift. Then next move to thrust. What is thrust? Thrust is, we know thrust is the forward force produced by the propulsion system like a jet engine or propeller, okay, that moves an aircraft through the air. It follows Newton's third law. Newton's third law means for every action there is an equal and opposite reactions. It's say by the Newton, when gas are expelled backward from an engine, or equal force push the aircraft forward. Likely swimming, if we push the water in back, we will move forward. That is called thrust, according to the Newton's third law. Then we move how the thrust will produced. We categorized propulsion systems into left side and how it thrust produced. These are categorized in four manner. Jet engines, they expel high speed exhaust gas backward. Jet engines expel high speed exhaust gases backward. Then we created more thrust. Then propeller blades push the air backward using rotating blades. Propellers push the air backward using rotating blades. It depends upon count of different blades and size and its airfoil shape. Okay. Then third one is rocket. Rocket expel combustion gases at a very high speed in a vacuum or air. Rocket expel combustion gases at very high speed in a vacuum air. Then fourth one is turbofan. Combine jet core exhaust and fan air from the efficient thrust. Combine the turbofans engines are combine the jet engine exhaust and turboprops also. Combine the jet engine and turbofan engines combination. This is the formula for thrust. We take a formula for a jet engine thrust which is equal to m dot into VE minus V naught, where thrust represented by the T, its the unit is Newton, m dot is mass flow rate of air and fuel kilogram per second, V is exotic velocity of gases represented by meter per second, and V naught inlet velocity of aircraft speed meter per second. This represents the thrust. And then what are the major properties included to create a thrust? The mass flow rate, velocity, exit velocity and inlet velocity of the aircraft. Then mass flow rate. The mass flow rate is represented by m dot, the amount of air and fuel passing through the engine per second. How much amount of air and fuel we passing through the engine per second. The more mass flow means more force expelled. According to the coordinate equation, how much amount of mass will flow, if the input is equal to output. Okay. More mass flow means more force expelled and give more thrust. Then exit velocity, it's represented by the V suffix C. Thrust increases with the higher velocity of exhaust gases exciting the engines. Thrust increases with the higher velocity of exhaust gases exciting the engine. Greater the difference between exit velocity and aircraft speed, greater the thrust. The difference between the exit velocity and the aircraft speed create the more thrust. This is the exit velocity and aircraft speed. Aircraft speed represented by V naught. As the aircraft speed increases, the relative difference with exit velocity decreases. Okay, as the aircraft speed increases, the relative difference with the exit velocity is decreases, and sometimes they are reducing thrust in some engines. Some engines have reducing thrust by this phenomena. However, in ramjets and scramjets, more speed it will be created. So due by the more intake and it will create more thrust. Ramjet and scramjets are having more speed by more air intake and more thrust. Then next is air density, rho. Already we see the density in lift generation. This is one of the factor to affect the lift. Air density, thrust is the higher in air denser air, which means low altitude. Thrust is higher in denser air. At high altitudes, air becomes thinner, less thrust. Understand? Denser air means we produce more thrust. Thinner means we produce in higher altitudes the air becomes thinner, which means its density is thinner. We produce less thrust. Rocket engines are independent of air and unaffected by density. Rocket engines are independent of air because the atmosphere is where it will work on vacuum and air also. Fifth one is altitude. As altitude increases, air pressure and density decreases, reducing thrust in air breath engines. As altitude increases, air pressure and density decreases, reducing thrust in air breathing engines. Jet engines lose performance at very high altitudes unless designed for it. Jet engines lose performance at very high altitudes unless designed for it. The next one is air temperature. Air temperature. Hot air is less denser, cooler air is denser. Okay, which reduces hot air, reduces mass intake. That's why we get lower thrust. Cooler air is denser. That's why we get more engine efficiency and increasing thrust. So air temperature plays a major role to create thrust. So in a cooler air region, we producing more thrust. Okay. By the next atmospheric pressure. Already we know what is atmospheric pressure and what is the value. The atmospheric pressure affects the pressure difference between intake and exhaust. Lower atmospheric pressure reduces engine thrust at a higher altitude. Lower atmospheric pressure at a higher altitude reduces engine thrust. Higher atmospheric pressure will available only in lower altitude and it will use to increase thrust. Then engine condition and design. This is the major thing to produce thrust. Variety of engines are available in a modern world. First one, new well-made engine produces more thrust. And the olden engines, olden model is produce less thrust during this life period. It will breakdown will be appear. Then engine upgrades, bypass ratio, nozzle shape, materials also plays a main factor to design well engine can encourage thrust. Then the nozzle design. In jet engine, rocket engine, nozzle plays a very important role to produce high thrust. If the convergent divergent nozzle optimize exhaust speed. Once again I repeat you, convergent divergent nozzle optimize exhaust speed. The shape of the nozzle also affects exit velocity. There is a bell nozzle, cone nozzle, arrow spike nozzle, whatever it may be. Then may be divergent nozzle, convergent nozzle. These also affect the exit velocity of gas. It also influences the thrust. Then move to third, aerodynamic forces. What is drag? Drag is the aerodynamic force that opposes the motion of an object through a fluid like air. In flight, it acts opposite to thrust and tries to slow down the aircraft. Drag is the aerodynamic force that opposes the motion of an object. If a plane moves forward, drag pulls it backward. Already we see if the boat is forward, it will see in water is a water medium. If the boat is move forward, the drag will follows the boat continually backward. The first one is classified. The drag is classified: parasite drag, wave drag, form drag, skin friction drag, interference drag. These are the classification of drags. Drag not associated with, then is this called parasite drag. Drag not in general, drag is also associated with lift. Okay, but by the parasite drag not associated with lift, it increases rapidly with speed. If the flight speed increase rapidly, then we cannot create parasite drag. The parasite drag is which is equal to form drag, skin friction drag, and interference drag also. Form drag, that which means pressure drag. It is caused by the shape of the aircraft. The shape of the aircraft plays affect the form drag. The shape of the aircraft, if the aircraft is square shape, it will create more form drag. That means pressure drag. Bulky shapes like blunt noses or external landing gear increases resistance. Bulky shapes. More streamlined means less form drag. If the airflow is streamlined, it will create a more streamlined, it will create form drag. Then skin friction drag. Skin friction drag means caused by air striking to the aircraft surface due to the frictions. That depends on surface roughness and cleanliness. If the surface is too smooth, skin friction drag will be reduced. If the surface roughness is high, it will create more skin friction drag. It affect the aircraft thrust. Okay. Then polished surface reduces skin friction. The skin friction is very, very important. So we clean the surface regularly. Then interference drag. Interference drag means it caused when air flows from different parts of the aircraft wing, where it's the junction points. The junction points create the interference drags. Example, wing fuselage junctions. The wing root is attached to the fuselage of the aircraft. At this point, the interference drag will occur. Poorly blended intersections cause the turbulence. Once again repeat you, poorly blended intersection causes turbulence. Then second, move to induced drag. The induced drag results from generating lift. The parasite drag is not associated with lift, but the induced drag is associated with lift. It's caused by the vortices formed at wing tips due to pressure difference between top and bottom wings. Due to the pressure difference, the vortices will occur at wing tips. Sometimes the wing tips will be broken. If they increase with the higher angle of attack, and it will available in increase with the higher angle of attack, lower airspeed. Then third drag is wave drag. Wave drag occurs when an aircraft flies at a above transonic, which means 0.8 to 1.2 Mach number or supersonic speeds. It caused by shock waves forming on the aircraft surface. A major concern in high-speed flights, jets, missiles, it is reduced by swept wings, area rule design. Area rule design is nothing but narrow fuselage and near wings. Narrow fuselage, near wings. Okay. Then move to interference drag. Interference drag occurs at junction at different aircraft. I already said that can be minimized by smooth filleting or blending transitions. Then major aircraft parts and their functions. What are the aircraft major parts and their functions? What are the functions? It's available here. Aircraft are complex machines. It's made by 2 lakhs number of parts, made up of several key components, each playing a critical role in ensuring stable, control and efficient flight. Below are the major parts of an aircraft and their primary orders are available. First one is fuselage, that is the main body. What is the functions that hold the cockpit, passenger, cargo and attachment points for wings and tail. Fuselage is major thing. It carries passengers. It consists cargo, cockpit and attachment points for wings and tail. Types thrust track, that means frame structure. Then second one is monocoque and semi-monocoque, symbiote loads. Nowadays we using semi-monocoque structure for larger aeroplanes. Monocoque structure is a olden days structure. Only it carries 4 number of pupils only available. Wings function: provide lift by creating pressure difference between the upper and lower surfaces. Wings is the play a major role to creating a lift. The key components: ailerons and flaps. Ailerons is used to control roll and flap is used to increase lift during takeoff and landing. Empennage is tail section. It also calls a tail assembly, provides stability and control. Tail section is it is used to stability and control, to balancing the aircraft at any height, any altitude. Okay. It consists of horizontal stabilizer, elevator, vertical stabilizer and rudder. Horizontal stabilizer to use pitch stable, elevator to control the pitch and vertical stabilizer keeps the yaw stable and rudder controls yaw. Then fourth one is very, very important, power plant, that means engines. It creates a thrust to move the aircraft forward. Then types piston engine, that means propeller driven. Piston engine it using propeller driven. Then jet engine, turbojet, turbofan. The third one is turboprop or turbo shaft. Then fifth one is landing gear. Landing gear is the most important things to move the forward in runway. Function supports aircraft during takeoff and landing and ground movement. It only using it ground movement. In some aircraft, wheels are attached permanently. In some aircraft is retracted and extracted using the machine. Types of landing is tricycle gear, which means two main wheels plus one nose wheel. Dial dragger, two main wheels plus tail wheel. The landing may be retractable or fixed. These are the classifications. Then cockpit. Cockpit means flight deck. The function of the flight deck control center where pilots operates the aircraft. It contains flight controls, navigations, instruments and communication systems. In this figure, flight control service. What are the control services are we using in aircraft? The control service first one is aileron. It is placed in outer wing, nearby the wing tail. It is used to make a roll. Then elevator is a horizontal. It is placed in a horizontal tail. Which is used to make a pitching. And the third one is rudder. It is placed in vertical tail to make a yaw. Then fourth is flap or slats. It's placed in wing near the wing root. Sometimes it's placed in trailing edge of the wing. Sometimes it's placed leading edge of the wings. Most of the time, it's available only trailing edge at wing root. The lift encouragement is using the flaps. Spoilers, wing surface, wing upper surface. Reduce lift and reduce drag. If we need reduce the lift at a time, we using spoilers. Fuel system, it is very used one. Fuel system stores supplies fuel to the engines. It's located inside the wings or fuselage. Main thing, it located inside the wings or fuselage. And avionics, electronic system for navigation, communication and flight management system. Avionics is very important. It includes GPS, autopilot, radar, weather system also and etc. Also it's available in the avionics system. Electronic system for navigation, communication and flight management. Next we move to control surface of an aircraft. Control surfaces are movable parts of an aircraft used to pilots control and maneuver the aircraft in flight. The surfaces adjust the aircraft's orientation along the three axes of rotation: pitch, roll and yaw. Ailerons, it located outer trailing edge of the wing. Function, controls roll. Working, one aileron goes up while the others goes down. Upwing creates a less lift. Down ailerons creates more lift. Wing rises. Used for turning or banging the aircraft. Ailerons is used to turning or banging the aircraft. The elevator, it located the trailing edge of the horizontal stabilizer, that means tail plane. Function is controls pitch, rotation around the lateral axis. Walking, if the elevator up, nose pitches up. If the elevator down, nose pitches down. Used for climbing or descending. Rudder, it located at the trailing edge of the vertical stabilizer, then it is called fin. Function is controlling yawing, rotation around the vertical axis. Working, rudder deflects left, nose stands left. Rudder deflects right, nose stands right. Used for coordinating turns and correcting left drift. Flaps, it located at trailing edge of the wing near the fuselage, that means wing root. Function, it increases the lift and drag. Walking, external downward to increase wing curvature. Extended downward to increase wing curvature, that means camber. Used for takeoff and landing and slow it at safer speeds.
Then move to slats. Slat means where it is placed leading edge of the wing and its function is improve lift at low speeds. Slat means it is using to lift at low speeds, working extender forward to allow airflow over the wing at high angles of attack. It is used for delaying all during takeoff and landing. Then move to spoilers. Spoiler is located at top surface of the wings. It destroys lift and increase drag. Rise into airflow to spoil the lift on the wing. It is used for design, slowing down after landing, roll control in some cases. This is the engine, this is the propeller, the red color is defined fuselage, this is the landing gear, this is the tricycle landing gear, it has a tricycle landing gear. The fuel tank is inside the wings or placed inside the wings. This is the aileron, this is the yellow color represents the flaps. These are the tail empennage, the entire stabilizer is called as empennage. These two are horizontal stabilizer, these ones are vertical stabilizer. The orange represents the rudder, the green represents the elevator, the small places represents the trim tank. Location of the trailing edge of the primary control surface, especially elevator function, reduce pilot effort to hold controls in your position. To reduce the pilot effort, working set mechanically or electrically to take decide flight instruments. Applications of flight, transportation, airlines and cargo, defense means fighter jets, surveillance drones, space exploration using space exploration, rocket satellites, irrigation means gliding, hot air ballooning, emergency services means air, ambulance, fire fighting and helicopters. Thank you for your patience.